Right. So welcoming you all once again to the second class of this revision course, where we all will be doing the next remaining part of the course. We'll be continuing with the same. Right. So yesterday, as you all remember, we had started uh, measurements the unit measurements. I had told you all how all of us will be continuing with this uh, course, everything about it, the syllabus, right? So before we begin every class, we'll have a short meditation and short prayer, because I have a firm belief, as I told in the last class, on the Indian culture, right? Whatever we have been given by our ancestors, right? So I would request the same at your end too. Kindly join your hands, close your eyes. And if you can, please do repeat. Dear God, we are your children. We thank you for this life and all the favors, all the blessings of this life given by you to us. Thank you that we are alive in this moment. Thank you for good health, wealth, and wisdom. Thank you for guiding us and motivating us so that we can move in the righteous path and achieve our dreams as we have imagined. Thank you in advance that we are clearing JEE 2020 and NEET 2020 in flying colors. Thank you for all your guidance. Thank you that you are being able to put in our honest efforts and achieve the desired results. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. After this prayer, we'll have 3 deep breaths, one by one. Count 1. Breathe in. With a smile on the face, breathe out. Count 2. Breathe in and breathe out. Count 3. Breathe in and breathe out. With the same smile on the face, slowly and steadily open your eyes. Slowly and steadily open your eyes. Right. So, good morning once again, all of you. Welcoming you all to the second class of the revision lecture. Dear all, I have a couple of announcements today before we start off, right? So the first one, there have been students who have been still requesting me that if they can still be a part of the course. So keeping in consideration the overwhelming response of the students across the country, I have decided that this course will have the new joinees, the new entries who can come in, right, and join the regular classes as we have already started. Before they join, they'll be expected to watch the videos of the recorded lectures of this class, right? The recorded lectures of these class will be available on a link which I'll be sending you all in due course of time, perhaps by today, latest by tomorrow, right? So that link will consist of all the past lectures where any student who wishes to join the class, or any of you who wishes to revise what we have read in the last class, I understand that might be need of the hour. You might feel the need to again review the lecture. So for the same, a link will be given to all of you, right, on the group itself, where you can access these recordings of the prior class, as well as those students who are willing to join again, right? This is one. Second one is that I have decided that this course is free when it comes to money, but it's not free when it comes to hard work. There are many students who tend to confuse hard work with money. When you see that something is free, you start thinking, your brain is tempted into thinking that everything is coming free, even like free of hard work also. But it's not the case. The course does not levy any money on you, any charges on you, but still it is paid. How? The course wants you to work hard. That is the cost that you need to give me, right? So I'm no longer going to call the course as free. The course is paid, and the payment that you're going to give me is the hard work. So the hard work is, when you are in the class, stay focused on the moment, right? Listen to the lectures attentively, participate in the discussions. Wherever you have queries, do ask. So your asking is the payment you're giving me, right? So please remember that the course is paid. How? With your hard work. You're paying with your hard work to me, right? Then uh, you're attending the your assignment clearance lectures, that is the clarity lectures, every day in the evening from 7 to 8 is the cost that you're paying me for the course, right? Because until and unless you don't practice, you're not going to improve. In order to improve, when you have this golden opportunity, make the best of it, right? That is how you're paying me. Make the best of the opportunity, work hard. That is what the payment you're going to give me, right? So that was the second announcement. I hope I'm done for now, right? Uh, there is one more thing which is not an announcement but a technique which I wanted to teach you all, by which you all can regularly practice with the mock test. So I hope you all are very well aware there is an agency by the name National Testing Agency, NTA. So this is the one, NTA, National Testing Agency, right? I hope you all must be very well aware with the name National Testing Agency, right? So this particular agency or this particular organization is responsible for conducting your NEET and JEE examinations. So there is one important aspect about preparation for your JEE exams. If you go and talk to the toppers, no, of the exams like GATE, of the exams like JEE, of the exams like NEET, you will come to an understanding that all of them not only prepared very well, right? They prepared well, but at the same time, they practiced well. So what is the practicing that I am talking about? I am talking about stimulation of the exam time. So call it as simulation of exams, right? That is called the mock exams. So your mock test papers are available on the website by NTA, right? On the website by NTA. And these mock papers enable you to get accustomed to, or to get accustomed to the classroom environment, which will stimulate your growth, your mindset, that how do I actually make sure that I am present in the class itself. So it is not only these revision lectures which I'm organizing for you, but also you all have to make sure that you have a lot of time during the day. Take time and solve these mock papers. I'll show you how in a matter of time, right? Do solve the mock test papers which are available, irrespective of whether you are a NEET candidate or whether you are a JEE candidate. Solve the past year question papers of both. right? Whether JEE or NEET. This is one of the secrets that I'm letting you out, right? That the NEET and JEE papers will have exchange of questions. If you observe the past year papers of both, you will realize that there is exchange of question types in both the exams. The students appearing for NEET, if they see the past year JEE questions and vice versa, that is the students of JEE, if they see past year NEET questions, they'll have a very profound understanding of the new type of questions, which will have a high probability of appearing in the current year's paper. So please remember, solve all kind of physics papers, because again, physics and chemistry is common for both streams, right? So make sure that you take the best advantage of it. At least solve one paper every day. So please solve one paper every day. This should be your step one, right? So when you solve one paper, make sure that the questions which you're not able to understand, revisit those concepts. So your process does not end here. Solve, then check how many questions are right and wrong, right? Check your paper, right? After which you'll have to revisit the concepts, right? Revisit the concepts or keep them as doubts, right? Then when we are organizing the evening classes for clarity purpose, come to those classes, ask those questions. That, sir, so and so question I had tried, or maybe this is the question of JEE-19 or maybe NEET 2018. Kindly help me with the same, right? So apart from discussing the assignment questions, we'll also discuss those questions which you have tried, right, and not been able to make it, but only when that particular topic is going on. So if the class is for kinematics, you will be expected to ask the questions in kinematics, right? So this is how we are going to proceed. So please do remember that revisit the concepts, revise them from whichever lecture notes you might have already made, right? Whichever books you might already be having, please refer them, and you will see that you will have a tremendous learning growth curve. Your growth curve, your marks curve will have a very good ascent. It will keep on increasing. Please make sure that you start solving at least one paper every day. So if you have 30 days for your paper, right, or if you have 20 days for your paper, start off and keep solving at least one paper every day, so that you're done with 25 papers at the end of 20 days or 25 days, right? So this is the story, something very important I wanted to highlight. I'll share with you how do you access the papers. So here is the way. I'll be sharing with you all how do you actually find this out. Yeah, so I'll share my screen with all of you, right? So I hope everyone is able to see my screen. In case you're able to, can you please raise your hand? In case you're able to see my desktop where I've written National Testing Agency, please raise your hand. All right. So I think everybody is able to see. Right. So on Google, go to the Google search engine, write National Testing Agency. Right. I think everybody is able to see. Right. Please keep your hand raised if you're able to see the screen clearly. Shri, Pratham, Mahila, Harsh. In case you're able to see the screen, please raise your hand. Right. Pratham and Shri. Yes. All right, right, right. Thank you. You now you may bring your hands down. So you have to go to Google search engine, right? Uh, Click or write there National Testing Agency. Click on the website. Here, as soon as you go in, you will have mock tests available. See, you have an option of mock tests available. So I'll bring my mouse here, right? Yeah. So you have different options available here: home, about us, student, institute, agenda, right? So here there'll be an option for mock tests, right? Yeah. Either it will flash here on the screen or you'll have it somewhere around. Yeah, yeah. So here you go. This is the one, mock test. Click on it. You'll have this option appearing in front of you, MHRD, Ministry of Human Resources and Developments. Here you'll have to select the exam. So say if you're taking JEE mains, click on JEE mains here, right? Select the paper. There are so many papers, right? Of the April shift of 2018, 2019, right? So select one of the papers. Let's say I'm selecting paper 1, 11/01/2019, and then click on start mock test. Open the test, right? You need not enter any user or password, just log in, right? So this is the way, right? You'll have the instructions, and then as soon as you click on this part, proceed, right? You'll have to accept the terms and conditions, do that, click on proceed, and this will direct you to the question paper. So this is actually going to stimulate your brain, right, into solving such questions from the past years. See, have a look. For example, the question given: the speed, acceleration, and force are considered as fundamental units. The dimensions of Young's modulus will be, right, and so on and so forth. Then click on save and next. You will go to the next option, right? Maybe say you select option number 1 or maybe option number 2, whatever for that matter, right? And then you mark and review maybe for the next. You go to the next question, you have the question, right? You solve this one and then you move to the next again, right? Or you can click here on, as soon as you submit the test, you can click here on submit and get going, right? So here are the list of questions, I believe, right? These are the different questions here. So there are 100 questions, as I can see. Yes, so this is what I wanted to highlight for all of you, that please make sure that you have this regular habit of just taking one paper and solving it out. Revisit the concepts, revise it, right? I'll tell you what happens. Initially, if your preparedness is not very high, I'll tell you why do students hesitate from giving the paper, because they think that they are unprepared. Students think that they are unprepared. So let us first prepare and then start solving. When will you get prepared? You have completed your 11th, your 12th, right? There's 1 month to go. There is no point of time where you can say, I am done with everything. Physics is a subject where you can keep learning and learning and learning, right? And the best form of learning is to remove this word from your mindset. Know that whatever is the condition, whether I am prepared or unprepared, I will start solving the papers. Start solving the papers. If you think that you're not able to revise concepts, no, don't worry. First, attempt all the questions which you can make in one go. Attempt questions, right, which currently, right, solutions for. So the questions which you can easily make, attempt them first, submit, right? Submit. And also at the same time, make a list of the questions which you could not attempt, right? Revisit them, as I just told you. List of questions that you could not make, right? This is going to be your strategy. Point 1, attempt the questions. Point 2, submit them and have a list of questions which you could not access, right? Again open the same paper, because it is not taking any username or credentials, right? So you can open the same paper n number of times, open the same paper and then appear for it again. This time sit with your book or your notes, right? Whatever, wherever you have your formulas etc compiled in one copy, or any book you're preparing for, sit with that and again solve the paper, this time with the help of the book, right? And very clearly make a copy, right? In that copy, write down the past year question and the solution. It can be from the book also, right? Make sure that you do this every day. This is going to boost your preparation like anything for your coming examination. I hope my point is clear. If there is anybody who has any doubt with this, please raise your hand and you may ask. Yes. With this question solving approach every day, if anybody has any doubt, please raise your hand and let me know. Yes. Clear for all? All right. If it's clear, we'll start off. Once back, we'll bounce back to our regular work. Everybody, please remember it is the regular question paper solving which boosts your preparation, not just practice. You have to practice in the environment which will stimulate your mind or which will help you get simulated environment. Okay, now I'm sitting on the examination hall. I have these questions coming up. I have to solve them out, right? Get going, and I'm sure you all can do it. Try it out. If you face any difficulties, let me know. You can share them with me on my WhatsApp number with all of you. You need not share it on the group. You can directly talk to me on my WhatsApp number, right, and ask if you have any difficulties regarding this. We'll discuss a solution for it, right? So next we are starting off once again with the syllabus. I hope everybody has written this down. In case not, take a minute and jot everything important from this page. Yes. Do remember to revisit the concepts, right? Revisiting the concept is super important. To be not be able to make a question is okay, but revisit it so that next time when it comes, you can make it. Or a similar question comes, you can make it, right? So let's restart where we were. Restarting with the content, we were on the chapter measurements. Right. So this particular chapter, yesterday we had seen different kind of errors, right? Today we are going to see the topic first. Let's take dimensions, right? So I hope you all are very clear what are dimensions. I'll revisit the concept. So dimensions are basically uh, length, mass and time expressed in this manner: length, mass, time. There are some quantities like length, mass, time, current, which is denoted by A or ampere, and temperature, which is either denoted by theta or by K, right? So whenever you express any quantity in terms of these variables, you call their powers as dimensions. I'll repeat, right? Let's say the powers are A, B, C, D, and E. I'll repeat. Whenever we express any quantity in terms of length, mass, time, current, and temperature, the powers of these are called dimensions, right? Example: suppose you have a quantity called speed. We all very well know that speed is nothing but distance traveled by time taken, right? Distance traveled by time taken. Now that we know that this is nothing but distance by time, how are we going to put it into the dimensional formula which we just talked about? Simple. What is distance? Distance is nothing but length right? The unit of distance is meters, SI unit. So I'll write here meter per second, right? Easy to remember is, see what are the units you know. Meter and second. Meter is the unit for length. Second is the unit for time. So this becomes L by T. You'll express this as L into T minus 1. Now, the other quantities have power 0. So you can write M power 0, right? Enclose it within brackets. We all know. We will call them MLT. Take the powers as 0, 1, minus 1, right? So you will call that these powers, so basically these powers 0, 1 and minus 1 are called as dimensions, right? These are the dimensions in terms of mass, in terms of length, in terms of time. I hope this is clear to all of you. Now, there are some specific quantities in physics which you have read about. Let's say force, right? How will you find it for force? You know that force is by Newton's second law, mass into acceleration. So its dimensions will be given by multiplying the dimensions of mass and acceleration, right? Dimensions of mass are m, acceleration is velocity change per unit time, right? So change of velocity or the rate of change of velocity is acceleration. So you will have the units are kg, and for acceleration are meter per second square, right? So you will write mass L T minus 2. Why? This is length per unit time square. Let's see, meter per unit second square. So as soon as I see that, I'm going to write it as L into T power minus 2. So what are the dimensions then? MLT minus 2. Simple. We know force is, we know work is dot product of force and displacement. So I can write work, W is the dot product of force and displacement. So we write it as Fs cos theta, right? So how are we going to write the dimensions for work? The dimensions for work will be dimensions for force, that is MLT minus 2, into dimensions for S. Dimensions for S is displacement, dimension is length. So L cos theta has no dimension. So there are several quantities which have no dimensions. So they are called as dimensionless. They are called as dimensionless. Example of dimensionless quantities: angle, right? Angle is a dimensionless quantity, right? Exponential term like e power x, right? So this e power x doesn't have any unit as well as any dimension. There is no dimension to e power x, right? Similarly, angle also has no dimension. Then you have log of x. Here x also has no dimension, right? Log term also has no dimension. Similarly, here this x also has no dimension, right? Remember, these are some of the quantities like e power x. So x has no dimension. Angle, say I say 20 degree or 20 radians, right? Whatever, has no dimension. Very important. Keep this in mind, right? Keep this in mind and write this down. Take a minute, absorb what I have said first of all, and ask me if you have any queries in this. Yes. So, yes, class. Anybody with any query, let me know. Please raise your hand if you have any query with whatever I've written on the screen. Okay, let me see. Yes. So, anyone with any queries, please raise your hand. Right. I hope this is clear for all. Then we'll start off with the revision part of it, the solving part, right? So let's say you have this question from past year AI EEE 2003. Have a look at the question. AIEEE 2003, right? The question asks that which of the following quantities, write it down, which of the following quantities in your copies, which of the following quantities have same, have, sorry, do not have the same dimension, do not have same dimension, right? Which of the quantities do not have the same dimension? Okay, before you solve this question and I give you with what are the quantities, I'll tell you all one thing. I have a list of different dimensions given on one page, right? Of different quantities. Let's say you have a quantity called permittivity, right? You have a quantity called permeability. You have a quantity, let's say you have a variable called as H or Planck's constant, right? Similarly, you have so many quantities or so many variables. Uh, all you need to do is to remember their dimensions. Now, several students ask me that, sir, how do we memorize them? So I think there are around 40 variables for which I have the dimensions written them down on one sheet of paper, right? So, or printed on one sheet of paper, right? So I think there are 37 of them. I'll send you a sheet on the group, right? It has 37 quantities and their dimensions, right? So your task is to learn the dimensions and the quantities. I'll tell you how, right? To learn all 38 or 37 in a day is a very big challenge. But how do you make it easy? Learn 5 a day. In 7 days, you're done with 35. Easy? Start it off today, right? I'll tell you once again, you have 37 quantities and their dimensions. So I'll directly write them here. So let's say the first one given on this is for volume, right? For volume, the dimension is given as L cube. We all know, right? Now let's say the next one given here is density. Density is mass per unit volume, right? So the dimension will be M upon L cube, which is ML power minus 3, right? So these are the dimensions, right? Now in this you have 37 quantities, each one with a dimension. You have to make sure 5 dimensions a day, right? I'll take test every day. 5 dimensions. What are the 5 dimensions that you have done for the day? Every day we'll have a short test, right? So that, and that can be a surprise test as well. Someday I might take it, someday I may not, to ensure that everybody of you are learning it in your homes, right? Am I clear, everyone? Right? So those who have understood this point, please raise your hand. Those who have understood this point of memorizing 5 dimensions a day, please raise your hand. 5 dimensions a day. Who can understand this point that every day you have to go ahead with solving 5 dimensions a day. All right. All right. Continuing with the question, right? So the question tells you, that identify that which of the two variables do not have same dimensions, right? And the options given to you are, first one, torque and work. Torque and work. Second one is momentum and Planck's constant. That is P and H. Momentum and Planck's constant. Third is stress and Young's modulus. Right? Fourth one is speed, and there is a term given, mu naught into epsilon naught to the power of minus 1 by 2, right? You have to identify which one of these pairs given do not have the same dimensions, right? So please make a note of the question. I'm solving it here. So the students who had raised hand initially for for signaling that they have understood that they have to solve or learn 5 dimensions a day, those students who had raised hand earlier may bring their hands down. Thank you. Right. So we'll take doubts also. First, let us solve this. How do we do it? How do we do it? See, we know the dimensions for, suppose you don't know the dimensions for torque, don't worry. See, do you know the formula? So for such questions, what is the approach? I'll tell you. For such questions, the approach is, try and think that, do you know the formula? Do, or first of all, do I remember the dimensions? First question. Do I remember the dimensions? If you remember the dimensions, then it is very easy to recall and then match, right? This is step number 1. Suppose you do not remember. So there can be 2 cases. Either you do remember or you don't. If you remember, then the case is solved. If you don't remember, see that, do I remember the formula? Right? Now, if you remember the formula, then what do you have to do? You have to write the formula. See, you know that torque, which is represented by tau, is given as the cross product of this position vector and force, right? So I know that basically here I'll have L, and dimension for position vector is L, right? And dimension for force, we just saw MLT minus 2, correct? So we'll have the dimensions for torque as ML2 T minus 2, correct? What do you have to do then? See what is the dimension for work, right? We just saw the dimensions for work are again dimensions of force into dimensions for displacement. Cos theta doesn't have any dimensions, right? So you'll have ML2 again T minus 2. What does this tell me? This tells me that the dimension for work and torque are the same, right? So here we have same dimensions, right? Now let us see stress and Young's modulus. I believe in case you had solved yesterday's assignment and attended yesterday's class, you will remember that I had written, I'll write it here, Young's modulus is given by stress by strain, stress upon strain, right? This strain is a ratio. It has no units and no dimensions. No dimensions. What does this mean? That the dimension of y, is same as the dimension of stress. So yeah, this is stress. Stress by strain, right? So I know what? As strain is a dimensionless ratio, therefore Young's modulus, as strain is a dimensionless ratio, therefore Young's modulus and stress have the same dimension. I know this, right? And therefore here also we have the dimensions are same. How about speed and this value? I hope there is a chapter which you all have read, electromagnetic waves, where you'll read this, that the speed of light is given as 1 by under root mu naught into epsilon naught. Note this with you in case you haven't already. Speed of light c is given as 1 by under root of mu naught into epsilon naught. Write it down, and therefore you will have the dimensions of both LHS and RHS are same. What is this? C is the speed, right? And how can you express the RHS? RHS can be expressed as mu naught into epsilon naught whole power minus 1 by 2, right? Once you understand this, as soon as you do, you quickly have to write here, yes, the dimensions are same, right? So what have we understood? That the dimensions of torque and work are same, dimensions of stress and Young's modulus are same, dimensions of mu naught and epsilon naught are same. So here is the keyword, key for the day. Please make sure that you remember the dimensions according to the trick I have told you, 5 per day. For 5 quantities per day, memorize the dimensions. I'll be uploading here on the group, right? So I'll be uploading it here for all of you on the group, right? I hope you all have seen the contents of the syllabus which I already uploaded yesterday, and also you have solved the assignments, right? Now coming to, before I go to the next question, anybody who has any queries, just let me know. Yes, please raise your hand in case you have queries to ask in this question. Anyone or anything related to this question. Yes, class, please go ahead. All right, let me check. If there are any queries, you can let me know. Okay, I see that there are no hand raises. Okay. In this way, I am assuming that all of you are clear with what I have said, right? So this was the aspect, one aspect of such questions of dimensions, right? Now, let me take one question from NEET examination, and that question is based on the concept called as principle of homogeneity. Write this down with you. Principle of homogeneity. I'll rub everything on the screen, right? Have you written it down, class? In case you have not written it down, please raise your hand. I'll wait for you, don't worry. In case you have not written it down, whatever is there on the screen, please raise your hand. All right. All right, then I will rub the screen in that scenario, right? Please make sure that you will be remembering 5 dimensions a day, right? This is the key. If a task is typical or challenging, all you have to do is split it into parts. Every day some part will be done. So altogether you will be able to complete the entire task in no time, right? Yes. So next is, write down here along with in your copies, principle of homogeneity. What does principle of homogeneity tell you? Principle of homogeneity tells you two things. Point number one, LHS and RHS in an equation have same dimensions. One. Second, right? Quantities which are added or subtracted will have to have same dimensions once again. Now giving you an example, what do I mean, right? So let's say we have an equation. I'll take an equation, let's say, yeah, V is equal to U plus AT. One of the simplest equations we know, right? From kinematics, where V is final velocity, U is initial velocity. V is final velocity, U is initial velocity, A is acceleration, and T is time. We all know this, right? Now, see the law, right? What does this principle tells you? This principle tells you, first point, LHS and RHS, that is the left hand side and the right hand side in the equation, should have the same dimensions. See the LHS here. LHS is speed. Dimensions for speed will be L into T minus 1, right? Check out now that what does the law says? Law says that here for all of these terms, that is the RHS, the dimension should be again same as LHS, that is LT minus 1, right? Now see the second law. What does the second part of it says? Quantities which are either added or subtracted will have same dimension. Now check out here, this side. Which quantities are being added? U is being added to 80. What does this mean? That dimension of U should be equal to the dimension of 80. Very simple example to help you absorb the question. Now dimension of U will be equal to, again it is velocity, initial velocity, so LT minus 1. Dimension of AT will be dimension of A into dimension of T. What is the dimension of A? LT minus 2. What is the dimension of T? Is simply T. So what is the net dimension? See, L into T minus 1. Correct? Simple algebra, right? So this is what I wanted you all to realize with this example. Correct? Anyone who has any query with regard to the principle of homogeneity or with regard to the example that I've given, please raise your hand. With any query, if you have any query, please raise your hand. Yes. All are clear. Sure. Because if you're clear, I'll ask you to solve a question, right? So you'll have to try it out. You cannot step back then. So if there is anything, even the slightest or minutest query, be very clear. Take a minute to absorb what I've said. Take a minute to absorb whatever I have said. Yes. Yes, class. I'm giving you a minute. Absorb whatever I've said. And raise your hands and ask me any query you have. Yes, I'm waiting, class. So meanwhile, I'll be taking your attendance. As I've told you, please make sure that you're regular to the class, because one class we may read a concept, next class we may apply it into some other question, and in case you're missing out on classes, you'll end up in not understanding that concept, right? So to prevent that from happening, please be regular to the morning as well as the evening sessions of practice, right? Yes. Any queries, anyone? Please raise your hand if yes, with regard to the concept told. All right. All right. So let us see then the questions from past year with regard to the principle of homogeneity. I'll rub this example, right? Just a minute. So yeah. So write down this question with you. The question says that you have a quantity called as, I'll just write it down here, right? It is given, this is a past year AIPMT or NEET question. It says that refractive index, this is past year either AIPMT or NEET question, right? Refractive index mu is given as a plus b by lambda square. A is equal to mu is equal to a plus b by lambda square, right? You are being asked something. Now our question is based on the same. You are being asked what is the dimension of B. This is what the question says. Some parts I'm adding to it. Also find out what is the dimension of A, right? Also find out what is the dimension of AB square and A by B and B by A? Yeah, go ahead and find out the dimensions of AB square, A by B and B by A. Try it out, everyone. How will you do? See, have a look. So have a look at the formula which we just read. What does the formula say? Right hand side and the left hand side will have same dimensions, as well as the quantities added and subtracted will have same dimensions, right? Keep that in mind. What does this mean? That these terms A and B by lambda square, these terms will have the same dimensions as mu. What does mu mean here? It is refractive index, right? Refractive index is a ratio. I hope you all remember, right? Sin I by sin R, right? So refractive index is a quantity or a ratio such that it has no units and it has no dimensions. So it is dimensionless. What does this mean? Its dimensions are M0, L0, T0. Why? Because just few minutes ago we had read what are dimensions. Dimensions are these powers of length, time and mass. So since the powers of length, mass and time are 0, that is why this quantity refractive index is called as dimensionless, right? So what are you going to do here? You are going to write therefore, as mu is dimensionless, therefore we have A is also dimensionless. That is, A is also has dimensions M0, L0, T0, correct? Then what will be the dimensions of B by lambda square? Again, the dimensions of B by lambda square are also 0. Why? Because see the second law or the second point of the principle, quantities which are either added or subtracted, right, will have to have same dimension. So here when I'm writing plus and minus, please don't take it as positive, negative. It is added or subtracted. Added and subtracted. Quantities which are added or subtracted will have same dimensions, right? And therefore mu A and B by lambda square will have no dimensions. Now, how do you calculate the dimension for B? Simple. What will be the dimension for lambda square? Take it on the other side. Lambda square will have dimensions as L square, right? So you will take, I'll write it down here once again. Have a look. On the left hand side of the screen, I'm rubbing out the law. I hope you all have written it down, right? Please write down as soon as I'm dictating. Please make good running notes of the class. Although I'll make the class available online for access of all of you, right? But then still you are supposed to make sure that you are making class notes. Unless you do, as we had discussed yesterday, you won't be able to gain a good clarity, right? So you'll have B is equal to lambda square into M0, L0, T0, correct? Now what are the dimensions for lambda square? Dimensions for lambda square is lambda is wavelength, right? So since lambda is wavelength, we'll have dimensions for lambda is same as direction of length, and therefore lambda square will be L square. L square into M0, L0, T0. This will give you M0, L2, T0, correct? So you have dimensions for B, you have dimensions for A. Dimension for A is 0, 0, 0, right? And dimension for B is M0, L2 and T0. That means it has only dimension in length. There is no dimension in mass and time for B, right? So these are the part of the answer or answer of the part 1. This one we have solved. What are the dimensions for A and B, right? Now how do you find out dimensions for AB square? Simple. AB square, right? How do you do it? dimensions will be dimensions of A. It is dimensionless, right? So M0, L0, T0, correct? Into dimensions of B square. So see what I am doing, understand this, that I am replacing the variable by its dimensions, right? So write this down, key with you, write this keynote with you. What you have to do, the note is replace the dimensions or replace the variable with its dimensions, with its dimensions. Written it down, write it down, replace the variable with its dimensions. Right? So based on this, we are going to take one more question from past year JEE after this. Right? So what you're going to do, right here B, dimensions of B. What would be the dimensions of B? M0, L2, T0, right? So you'll have M0 net final value M0 L power 4 T0, correct? So this is the dimension of AB square. Am I clear, everyone? If I am, please raise your hand. If you're able to clearly understand this, please raise your hand. Else you can unmute yourself and ask later. Yeah, I'll give you the time. Please raise your hand if your understanding with regard to principle of homogeneity and its application into questions is clear. Yes. Atul, Bhavya, Harsh, let me know. Mugundan. Okay, Atul, Harsh, Pratham, Shri. Yes, guys, let me know. Any queries, just forward them to me, right? You can also put them by message if you wish. If the mic ain't working at your end, please raise your hand in case you have clearly understood. Pratham Devarkar, dear student, are you able to understand this concept? In case not, just freely let me know. Yeah, we'll discuss on it. No worries. Yes, Pratham, tell me. Any queries? All right, all right, all right. Pratham and Shri. Yes, Shri. Any queries at your end? Maybe you can raise hand so I'll know in case you uh, don't have any query. All right. So Pratham and Shri, you can forward me your queries by chat in case you have any. Right. All right. So class, please note this down. Whatever I've written on the board in your copies. Now you can bring your hands down. Thank you. Yeah. So assuming that all of you have understood by like your response, let us take the next question. Okay, Siddharth, is any question you want to ask? Yes, Siddharth. Okay, Mugundan, any questions? Yes, please let me know. All right. So, okay, no worries. In case your hand was raised by mistake, no worries. That's okay. Yeah. So, class, let us move to next question, right? If you have written this down, I'll rub this part. Anyone who remains to write? Okay. The next parts, A by B, B by A, right? I hope you're clear how you're going to attempt it. In case any queries, you can always forward them to me in the evening sessions, right? All right. So your assignments will be based on these questions, right? Please remember that questions which you're solving here, your assignments will be based on them, right? Okay. Now the next question, next variety of questions which you get, and these are so important that you get such questions every year, almost every year, right? In one or the other shift of NEET as well as JEE, right? What are the kind of questions? They'll say you that currently we see that MLT, A, that is current, and temperature, that is K, are used to express any quantity, right? So these are the fundamental quantities in terms of which we express other quantities. I will repeat, these are the fundamental quantities in the terms of which we are expressing other quantities. What if I replace these expressions, right? What if I say that these are no longer fundamental quantities, rather we have some other fundamental quantities, right? So I'll take a question from this year, that is J, the last years, that is J 2019. The question says, I'll write down the question here: surface tension S, moment of inertia I, and Planck's constant H, right, are taken as fundamental units, are now new fundamental units, right? It is asking what will be the dimensional formula, what will be the dimensional formula for, what will be the dimensional formula for linear momentum, that is P, right? What does this mean? Read the question again. Surface tension S, I'll repeat here, I'll write down here what are these quantities. This is surface tension, right? Moment of inertia I, right? And Planck's constant H, Planck's constant H are the new fundamental quantities. So you have to basically express P in terms of S, moment of inertia, and Planck's constant. This is the meaning, right? This is the meaning of fundamental quantities. That means right now, until now, we were expressing other quantities like B, etc., in terms of M, L, and T. Now you have to express momentum in terms of surface tension, moment of inertia, and Planck's constant, right? Question is clear, I suppose, right? So how do you do it? Very simple. The key rule, which we have just written over here, see on the RHS of the screen, replace the variables with it, replace the variable with its dimension, right? Do that. Do that. So first write that P, let us assume. So this is how the question will start, right? So I'll erase this. What you have to do, you have to first write down here, let us assume that momentum depends on surface tension, moment of inertia, and Planck's constant in this manner. See how? Surface tension raised to the power A, moment of inertia raised to the power of B, Planck's constant raised to the power of C, right? Let us take it this way. Now you are being asked, you are being told, and let's say there is also some constant k. Remember, we had told yesterday in yesterday's evening class, I taught you all that whenever there is a constant, you ignore it because it's a dimensionless constant. So let's say here this k is a dimensionless constant, right? So we are ignoring this dimensionless constant right now, correct? So you'll have, you can express P in terms of surface tension, moment of inertia, and Planck's constant in this way. Let us assume first, right? So we are taking this as A, B, and C. What is the step two? Step two is, have a look here. We just read, replace the variable with its dimensions. So for this, you should know the dimensions of surface tension, force, surface tension, moment of inertia, and Planck's constant, correct? So write down the respective dimensions. Any idea what is the dimension for surface tension? The dimension for surface tension is equal to, I think, just a minute, class. Yeah, resolving back, coming back. So this was linear momentum, right? So what is the first? Let's start from linear momentum. We know that linear momentum is given as mass into velocity, and therefore its dimension should be dimensions of mass, that is m, into dimensions of velocity, that is lt minus 1. So the dimensions of p should be mlt minus 1, correct? Point 1. Point 2, dimensions of surface tension. We know that surface tension's dimensions are, it is given as force per unit length, force per unit length, right? This is surface tension, we all know, right? So you'll have dimensions of force, that is mlt minus 2. We just read in the last question, dimensions of force upon dimensions of force upon dimension of length, that is L, right? So this will become mt minus 2, correct? Mt minus 2. This is the dimension of surface tension. How about moment of inertia? We know that moment of inertia is nothing but mass into radius square. Very simple. So this will give you moment, the dimension of mass, that is m, into dimension of length square, that is will give you ml2, correct? Similarly, you have dimensions for Planck's constant given as, where do you have Planck's constant? Try recalling. Planck's constant you have read in the chapter in class 12th. Try recalling, E is equal to h nu, right? Where this h is Planck's constant, E is energy, and nu is frequency, correct? So you can write Planck's constant is nothing but dimensions of energy upon dimensions of nu. Nu is frequency, right? So how will you write it down? See, dimensions of energy and work are same. We just read the dimensions for work, right? What will it be? Dimensions we just read, ml2 t minus 2. I'll try rubbing this line, right? ml2 t minus 2 upon dimensions of, upon dimensions of frequency. Frequency is time inverse, right? So it is t minus 1, correct? So what you're doing, you're basically try seeing that you're finding out what are the dimensions of momentum, surface tension, right, moment of inertia, and Planck's constant, right? Once you do, see, the dimension will be m l2 t minus 1, correct? ml2 t minus 1. This will be the dimension of Planck's constant, h. Once you are done with this, right, all you have to do is substitute these dimensions in place of S, I, H, and P. Okay. Until here, first absorb it. Let me know if you have any query. Please raise your hand if you have any query and ask. Yes. Yes, Mahila, tell me.
Sir, velocity equal to L into T power minus 2.
-1.
Why, sir? A meter per second square is the velocity, sir.
C. Velocity is given as distance or displacement by time, right? So what is the dimension for displacement? L, right? And dimension for time is T.
Okay, sir.
So what will it be? L into T minus 1. Clear?
Yes, sir.
Right?
Yes, sir.
So the dimension you are talking about is the dimension for acceleration. See, acceleration is velocity per unit time, right? So it will become, tell me, the numerator will be LT minus 1, right, upon T, correct? So it will become LT minus 2. So LT minus 2 is the dimension for acceleration. I'll bring my spotlight here. So have a look. LT minus 2 is the dimension for acceleration, and LT minus 1 is the dimension for velocity. Is it clear, Mahila? Yes, Mahila. Is it clear, the concept?
Yes, sir.
All right. So we'll move to the next. We'll move to the next part of this question, right? I hope everybody has written down the question with them. I'll rub the initial part, right? So here, what you're going to do is you'll write the dimensions in place of these variables. That is m, l, t minus 1. Dimension for momentum is equal to dimension for now surface tension, ml minus 2, right, power a. Then dimension for moment of inertia, ml2, right, power b. Similarly, dimension for h, that is ml2 t minus 1 raised to the power c. Now, do you all know this fact that whenever we have a to the power x given as a to the power y plus z, whenever the base on the two sides is same, this implies that x is equal to y plus z, right? Please note this formula quickly, everyone. Note this formula with you. Whenever the bases are same, we can equate the indices, and you can write it also. When, write a note, when bases are same, equate the indices, right? When bases are same, equate the indices. Written it down, everyone, quickly. Jot down the LHS and the RHS. I'll wait for a minute. Right? So what you have to do, I'll give you a short hint, and we'll break for 5 minutes for the session, right? So what you have to do is, on the LHS, I'm rubbing this, right? See, I am continuing this equation over here, right? Have a look. Group the similar variables together. So here on the RHS, what you'll have, m to the power of a plus b, right, plus c. Why? Because you all know that when you have a power y into a power z, What is the answer? A power y plus z. So here also see you are multiplying a m power a into m power b into m power c. Therefore, you will add the powers, right? Similarly, L power minus 2a plus 2b, right? And t power minus c. Correct? Now, use this principle which we have just told. Here, have a look this principle. That whenever there are similar bases, that is m and m, right? What you can do, you can equate their indices, that is powers, right? So you will have a plus b plus c is equal to 1, that is power of m. Power of L on LHS is 1, right? And power of L on the other side is minus 2a, sorry, minus 2a plus 2b. So you'll equate them. See 1 here equated to this value. Clear? Similarly here on the LHS, the power of time is minus 1. Here the power of time is minus c. Equate them, right? This is the basic agenda or the crux of solving such questions. Once you do, you will get three equations. What? A plus b plus c is 1, minus 2a plus 2b is equal to 1, right? And minus c is equal to minus 1. Solve these three equations. Whenever in mathematics you have a formula, whenever you have three equations and three variables, you can easily solve them. How will you solve them? Here, quickly, one by one. C is equal to 1, simple from this equation. Then put this C in the first equation. You will get A plus B plus 1 is equal to 1, right? 1 and 1 get cancelled. You have A is equal to minus B, correct? So when you have A is equal to minus B, how will you solve it? Right? So on and so forth. You can go ahead solving with the question. I might have here or there put some variable. Let us check. Let me check myself. So we have MLT minus 1. Then we have ML2 T minus 1 here. ML. I think I've done, okay, I've done a short mistake here. Just a minute. I'll correct myself. I think in the substitution for one of the two variables, I think this either first or second. Just a minute. Right? Surface tension is, pardon me for this, just a minute, right? So here the variables were, I'll write it down again. We had variables surface tension, inertia, right? And Planck's constant. I'm rewriting their uh, dimensions over here. For surface tension, the dimensions are, we had written it down, right? M T minus 2. I had mistakenly taken it as L minus 2. Pardon me for this, right? And here we had ML2, right? Moment of inertia. And for Planck's constant, we had M L2 T minus 1. Mistakenly, I had taken this as L, right? I think it was a writing error. So accordingly, we proceeded, right? No worries. But you all understood the concept, right? The concept is whenever you have such a question where you have to find out how does one quantity depend on the others, you have to write down their formula and assume that the powers are A, B, and C. Then you have to substitute respective dimensions and then equate the values. So here you will write MLT minus 1 is equal to, on the RHS you will have M power A plus B plus C, right? Here L will be to the power of, first in first term, see there is no L, right? So 0 plus, see here 2B, right? And here 2C, correct? Then you will write T, here the power is minus 1, on the other side it's minus 2A, right? Then you have again 0 in the center. See there is no T in the second term, and in the last term it's minus C, right? So you'll have three equations. A plus B plus C is equal to, equate the terms the same way, same technique. Technique does not change, right? Technique is same. Power of M on one side is 1, on the other side it is A plus B plus C. So you'll have A plus B plus C is equal to 1. Then you have 2B plus 2C is equal to 1, right? Because power of L here is 1, right? Then you have minus 2A. Just have a look here. This one, minus 2A, right? Minus C, correct, is equal to minus 1, right? So solve these three equations, find out the values of A, B and C, right? So how will you do it? One by one, take any two equations at a time and solve the other, or just take one variable, express the other variables in terms of it. So let's say here, when you solve them, you will get the values of A, B and C, right? The values of A, B and C will be in the fashion such that you will get A is equal to half, B you will get as again half, you will get C is equal to 0, right? So when you do that, when you solve these three equations and get these values, you can re-substitute them here, and the formula for try it out again once, right? The formula will be P is equal to, I'll write down it another color. You'll get the formula as P is equal to S power 1 by 2, right? I power 1 by 2 and H power 0. So we'll take a short break and we'll be back by 10:35, right? Yes, Mahila, you want to say something? All right. So we'll take a short break and we'll be back by 10:35, right? Okay. All right. So next, let us now come to the next part. Before we do, anybody, any queries with this part, whatever we have read until now, please raise your hand. Yes. Yes, Harsh, let me know. Yes, Mugundan, tell me. Yes, Harsh, please tell me. No worries. All right. I think it must be by mistake. No worries. That's all right. That's all right. Okay. So I'll rub this part, right. I hope you all are clear that how do you actually make sure that whenever you have to present one quantity in terms of the other, you just write down the formula, right? I'll revise it in one go. 1 minute. So let me rub all of this. So whenever we have to express one quantity in terms of the other, what do? I write down the formula. I take, let's say, momentum. I write in terms of force, mass, and let's say I say that there are three fundamental quantities: force, mass, and acceleration. Right? Now I say express momentum in terms of force, mass, and acceleration. Right? Force, mass, and acceleration. So how will I do it? I will take that momentum depends upon their power. Let's say A, B, and C, right? K is dimensionless. Again, what will I do? I will replace the variables with their dimensions, right? So momentum dimension ML T minus 1, right? Force dimension ML t minus 2, right? But make sure you will put the power, right? The power for force here is, we have assumed it is a. Then power dimension for mass is m, right? Then dimension for acceleration is lt minus 2, correct, to the power c. What you will do, m here, right? Power is 1. See what is the power of m on the other side? A. This is b, right? Pardon me, this is b. So I'll correct it up here. This one is b. Yeah. So m to the power a plus b, right? Here l to the power of a plus c and t to the power minus 2a minus 2c, correct? Now see on the other side, that is LHS, m to the power 1, l to the power 1, t to the power minus 1, right? So you will equate respective powers, that is, you will have 1 equated to a plus b, that is a plus b is equal to 1. Again 1 equated to a plus c, so a plus c is also 1. And also you have from the last equation, a minus 2a minus 2c is equal to 1. That is again a plus c is equal to 1 by 2, and so on, right? So I'm just telling you all that this is how you have to solve the question. I hope it's clear at everybody's end, right? So yeah, this is how you have to proceed. I'll go ahead, right? Please take a screenshot of this in case you would like to practice it later, right? Okay. You might not always be able to solve a few questions. So sometimes you might be given questions accordingly. I've just taken one example just to make the approach clear, right? Don't get stuck to this question. Yeah. So let us move next part. Yeah. So the next part we are studying, as we had started yesterday, try recalling, I talked about screw gauge and vernier calipers, right? This is something very talked about, screw gauge and vernier calipers. Vernier calipers, right? So the working of screw gauge and vernier calipers, how does it work and what are the kind of questions that are asked, right? So let us take them one by one, okay? So we have vernier calipers. First of all, we'll see this topic in three terms, right? First of all, how does a vernier calipers work, right? How its least count is given, working of vernier calipers, what is its least count, right? How do you take measurements from measurement and reading, right? And the last part is, what if there is a zero error? I'll tell you what is a zero error, right? Okay. So see, have a look. I will try bringing a screen in front of you to tell how does a vernier calipers work, right? So yeah, just a minute. Yeah, just a minute, right? So bringing vernier calipers diagram in front of you to tell you it's working. Yeah, so it's open up now. I'll be sharing my screen. Yeah, so I hope you all can see the diagram, right? So this is what is called a vernier calipers. First of all, what is it, right? What is it? So vernier calipers is an instrument which is used to measure lengths. Simple, right? I'll zoom it up. Yeah. So here, as you can see on the screen, that you have, see, so here we have a vernier calipers which is used to measure the length. First point, how do you measure the length? You keep an object between the two jaws, right? One is called the fixed jaw, this one. The other one is called the movable jaw. You bring the jaws together, keep the object here, right? And then all you do is take the readings, right? How do you take the reading and how do you measure what is the least count? So first I'll write here what is the least count. So you can see on the side, I'll write, just a minute. Right? So for a vernier calipers, please jot this down in your copies, right? This is a very significant question which has been asked several times in the past years, and this is also one of the high probability questions which might come this year, right? Okay, so have a look. Least count is given as, for a vernier calipers, 1 MSD minus 1 VSD, right? I'll repeat, 1 MSD minus 1 VSD. What is MSD? MSD is main scale division. Main scale division. What is main scale division? Main scale division is, just have a look here on the screen, right? So here, if I see the main scale, this is the main scale, right? This is just like your normal regular scales which you use, right? So in this scale, what is the minimum measurement that you can see? See, these are gaps of 1 centimeter each in which there are 10 divisions. That means the minimum length that you can measure with a regular normal scale in your homes, how much is it? 1 mm, right? So this main scale division is nothing but 1 mm. This implies minimum measurement you can take with the main scale here in case of finding out the formula, correct? This is the MSD here. Now, what is VSD? VSD is basically, I'll tell you what, right? So for this, I'll give you one question, right? I think that should make the matters clearer. So we have different questions coming up for this particular concept. Yeah. So suppose the question tells you, right, that in the question you will be given a data. Yeah. So just a minute. Yeah. So something like this. You will be given in a question, let's say that the 10th VSD, right, the 10th vernier scale division coincides with ninth main scale division, something like this. You will be given data in this form, right? Data for what? Data to find out what is the value of 1 VSD, right? So what you'll do, you'll write here from this statement, this implies that 10 VSD is equal to 9 MSD, right? This is the data given in the question. Then you will write, therefore, 1 VSD is equal to, what will 1 VSD be equal to? If you know 10 is equal to 9, so apply simple unitary method, right? You know if 10 chocolates come for 9 rupees, so what will be the cost of one chocolate? 1 into 9 upon 10, simple, right? Unitary method, that is 9 by 10 MSD. I'll repeat. Suppose if it is given that 30 vernier scale division coincides with, another example, coincides with 29 main scale divisions, right? So you will write 30 VSD. This implies, yeah. So this implies that 30 VSD is equal to 29 MSD. You will write this way, okay? Then you will have 1 MSD will be given as 1 into 29 upon 30 MSD. Am I clear? So what does this mean? For the two questions, let's calculate for both parts least count, right? So least count for the first one. What is 1 MSD equal to? 9 by 10 MSD, right? 1 VSD is 9 by 10 MSD, correct? So what you can write here directly, have a look. 1 MSD minus 9 by 10 MSD, right? That will give you 1 by 10 MSD. Correct? And what we have said that 1 MSD is equal to how much? 1 MSD equal to 1 mm. We are given in the question. You will be given in the question, right? We'll see the question. So you will have 1 by 10 into 1 mm, right? So what will give you the least count? Least count will become 0.1 mm. Correct? This is for part 1, this one. This is example number 2. Now let's take example number 2. First, jot this first example down, right? This was solution for answer number, question number 1, where we calculated. I'll repeat, what did we do? We have calculated least count for a vernier calipers, where we were given that 10 VSD was coinciding with 9th MSD. This is what the question will give you, right? So from that, first of all, you will write this formula. The formula is least count of a vernier calipers is given as 1 MSD minus 1 VSD, right? First you will write this. Then from here, from the given data, you will write that 10 VSD. If 10 VSD is equal to 9 MSD, then simple, by unitary methods, 1 VSD will be 1 into 9 upon 10. That is equal to 9 by 10 MSD, right? This is what we are going to substitute here. Why? Because we calculated what is 1 VSD. That is what we are substituting here, right? So you have MSD and MSD. So you have 1 MSD minus 9 by 10 MSD, which will give you 1 by 10 MSD, correct? In the question it will be given to you what is 1 MSD or main scale division equal to, correct? VSD is vernier scale division, MSD is main scale division. See these divisions on the main scale, right? The smallest value which you can take from the main scale is nothing but MSD over here, right? Now what do you do? Smallest value on the main scale that you can take is 1 mm. So I substituted 1 mm here. You get the answer 1 by 10, that is 0.1 mm, right? Calculate the similar, in a similar fashion, what will be the uh, calculation or the least count in the second case given. I'll give you the data once again, right? So this time you are given the question. I'll give you a past year question. So yeah, please note down, right? So I have a variety of questions. Let me see which one can be given to you all. Yes. So this one is from AIEEE 2019, 2009, right? A very good question based on the similar pattern. The question says, in an experiment, angles are required to be measured. Angles are required to be measured. Right? Now it says that 29 divisions of the main scale, 29 divisions of the main scale exactly coincide with with 30 divisions of the vernier scale, with 30 divisions of the vernier scale. VS, vernier scale. Okay. Now you have to find out if the smallest division, it is given, if the smallest division, of main scale MS is half a degree, that is 0.5 degrees, right? You have to find out the least count for the instrument. Least count for instrument. Just a minute. Least count for the instrument. Very simple and very scoring question. See, simple formula once again. What is the formula? Formula is least count is equal to 1 MSD minus 1 VSD, right? What does the question tell you? Question tells you that 29 divisions of the main scale coincide with 30 divisions of vernier scale. So you will write 30 VSD, 30 divisions of vernier scale is equal to 29 MSD. Correct? Then you will have therefore 1 VSD is equal to 1 into 29 upon 30 what MSD. What does this tell you? This tells you that 1 VSD is 29 by 30 MSD. Correct? Substitute this here. So substitute this expression that 1 VSD is equal to 29 by 30 MSD over here. Correct? So you will have 1 MSD minus 29 by 30 MSD. Correct? So you will get the answer as 30 minus 29 by 30 MSD. That is nothing but 1 by 30 MSD. Now you are getting least count. This is least count in terms of MSD, but you have been the options given in the questions are in terms of degrees and minutes. Degrees and minutes, right? So see what is the value of 1 MSD given. See, if the smallest division of the main scale is how much? 0.5. Do you remember just now I told you that on a scale the smallest division was 1 mm. So instead of MSD, we had substituted 1 mm. But right now, here the smallest division of the main scale for this angle measurement device is 0.5 degree. We are using an angle measurement device. See, in an experiment, angles are required to be measured. So this is a different device which is used to measure the angles. For that, we are getting 1 MSD is how much? 0.5 degrees. So substitute that here. Here you are given in the question 1 MSD is equal to 0.5 degrees. Correct? So substitute it here. You will have 1 by 30 into 0.5. Correct? Degrees. Right? Now, in case you all know it's good. In case not, I'll tell you the conversions in minutes and degrees. Right? So 1 degree is equal to 60 minutes. Right? 1 minute is equal to 60 seconds. Right? So the answers given are, the options given are in minutes and degrees. So see how much will this amount to? The answer which we are getting 1 by 30 into 0.5, how many minutes will it be? We know that 1 degree is 60 minutes, right? We know that. So I'll just drop some part. Have you all written the question down, Bachalo? I'll just write here. So you have 1 degree is equal to 60 minutes, right? So we will have this answer. What is the answer? Check it out. The answer is 0.5 upon 30 degrees. Okay, 0.5 by 30 degrees, the least count. So if 1 degree is 60 minutes, then 0.5 by 30 degrees is how many minutes? 0.5 by 30 into 60, right? Unitary method divided by 1. So your answer will be 1 minute is the answer. Least count is equal to 1 minute. Take some time, read the question again, try absorbing it, right? Whatever we did. I know many of you might have seen this for the first time. That's all right, right? Yesterday only we talked about in the yesterday evening's class. Whatever happened, happened. Forget the past. Right now you have a golden opportunity to recap your syllabus. Do it with all honesty. Simple as that. Wherever you have doubts, I am there for you, right? Have a look at the question, try absorbing it. I will repeat for everybody's convenience. This is a question where you had to find out the least count of the instrument. We have written down the formula for least count, right? And at the same time, we have made sure to understand that how will we convert VSD into MSD by the given condition. That is how this is over here. right? So on a similar pattern, even uh, your screw gauge works, right? Screw gauge, what is the difference? In screw gauge, instead of writing least count one MSD minus one VSD, you write one pitch upon number of circular scale division, right? Yesterday you have written down the formula for the same, right? So please revise these two, right? So this is how we have seen how least count works. Now, in order to understand the working and measurement, I might need your maybe 5 more minutes, right? So I'll show that how does it work. So I'll just move to the next question. But before we do, anybody, any queries, let me know. Yes, please raise your hand and ask any query you have. Yes, yes, class, please go ahead. Anyone, any queries in this concept? Clear for all? Sure. Abhinaya, Atul, Bhavya, Harsh, Krishna, Mahila, Monica, Mukundan, Pratham, Rashad, Shivani, Shri, Siddharth, everybody clear? All right. If you're clear, then I'll just explain in brief what is the working of a vernier calipers, right? Have a look. So in vernier calipers, basically we measure readings with a better preciseness, right? So I will rub this if you have understood well. In a vernier calipers, the working is very simple. See, you have a vernier scale, right? And you have a main scale, right? So as we just saw that here in main scale, you will have some readings, right? This is MS main scale, while this one is vernier scale VS, right? In vernier scale, you will have some divisions, right? So whenever you have actually hold it whenever you are holding that object over here, right, between the fixed and movable jaws, as you just saw the diagram, what happens is you have to take two readings from here, two measurements in fact. One measurement is in order to find out what is the value of or what is the length of a particular aspect, right? So you need two readings. One is called main scale division, MSD. The other is called vernier scale division, right? What is MSD? MSD is, write it down with you, that main scale division with which zero of vernier scale coincides. That means, have a look here. This is zero of the vernier scale, zero, right? There might be one here, two here, three here, and so on. So check that with which reading of the main scale, zero of the vernier scale is coinciding. This will be called as MSD. Am I clear? Now, VSD. VSD is, right, that vernier scale division which with which just a minute, with which any division of main scale coincides. Write this down first of all. Please write this down. Vernier scale division is that division on the vernier scale with which any division of the main scale coincides, right? So I'll tell you what I'm trying to convey with the help of a diagram. So here in this diagram, what you have to check, see, so here this might not be coinciding with any of the division. This also might not be coinciding with any of the division. This also might not be coinciding with any of the division. Try seeing on the diagram, right? See on the diagram what I'm trying to do. Except for one. See here, just have a look at all the vernier scale division apart from 0. 0 is coinciding with 1, we have taken that value, right? Now just see one by one all the vernier scale divisions. This might be first division, second, third, fourth, fifth, and so on till 10th, right? Suppose there are 10 divisions, right? Now you'll check that which division of the vernier scale is exactly coinciding with any division of the main scale. So I see that 2 is also not coinciding, 3 is also not coinciding, 4 is also not coinciding. But what am I seeing? Have a look at this one. This is the 5th division. I'll write it here. This is the, this was the 4th one. This is the 5th one. So I see that the 5th division of the vernier scale, this is vernier scale, right? 5th division of the vernier scale exactly coincides with some division of the main scale. This is any division, some or any division of main scale. That is irrelevant. What is relevant is this division which is coinciding from the vernier scale. Which is the division that is coinciding? See, have a look. It was the 5th division. See, have a look. I'll draw the diagram again. 5th division. Have a look. This one. Can you see? This is 5, right? Then you'll have 6, 7, and so on. But see, the 5th division of vernier scale exactly coincides with some division of the main scale. So in our case, VSD will be equal to 5. Right? Am I clear, everyone? How do you actually identify what is VSD? Right? Also, how do you identify what is MSD? So suppose this was second division, right? MSD is that division of the main scale with which 0 of the vernier scale coincides. So 0 of the vernier scale, see here, 0 of the vernier scale is coinciding with second division of the main scale. So you will write, in our case, MSD for the given example is 2. Am I clear, everyone? Right? Now, you have something called as MSR, that is main scale reading. And then you have something called as VSR, that is vernier scale reading. Main scale reading is given as main scale division into the smallest division on the main scale. Remember, what was the smallest division on the main scale? 1 mm. Smallest reading that you can have, right? So you'll write into 1 mm. Or you can also call it as least count of the main scale. Least count is what is the least counting or the least measurement that you can do from the main scale. I'm not talking from the device. There are different terms. Least count of any device is equal to the least measurement that you can make using that device, right? So you have MSR is equal to MSD into 1 mm and VSR is equal to VSD into 1 mm. Correct? Correct? So actually this is not 1. Just a minute. I'll change this. Yeah. This is VSD into least count of the apparatus or the instrument. Whereas here you will have MSD into least count of the main scale. Write this down. Now, least count of the main scale, that means the smallest division or on the main scale. How much is the smallest division on the main scale? 1 mm, right? Smallest reading. Now you will have, in our case, in the example that we have taken up, MSR will be given as MSD was 2, right? And main scale measures least value as 1 mm. So we'll have answer as 2 mm is the MSR. What is VSR? VSR is VSD, that is 5 into least count of the instrument. Let's say it is given in the question that the least count of the instrument, it is given, okay, least count of the instrument is equal to 0.1 mm. It is given in this question. So you'll write here 0.1 mm, correct? So your answer will be 0.5 mm. Now, what is the total reading equal to? Total reading is equal to MSR plus VSR, right? That is main scale reading plus vernier scale reading. That is 2 plus 0.5, which will give you 2.5 mm. Correct? 2.5 mm. What is this? This is basically the diameter of the ball that you are measuring. See here in the screen, on the screen, check this side. You are trying to measure the diameter of this ball, right? So the diameter of the ball comes out to be how much? This value. This value comes out to be 2.5 mm. Correct? 2.5 mm. So this is the value that we all were looking for, right? This is the value 2.5 mm is the total reading that we were looking for. Now, with a very small variation, what happens is sometimes when there is no device over here, that is, there is, let me say, there is no object over here. So let's say this is your vernier scale and this is your main scale and this is your vernier calipers. Suppose there is no device, but still you get some reading. Wow, how can this happen, sir? Sometimes it's happened because of the device faults, etc., right? That there is nothing here in between, but still you are getting some reading, right? You will take that reading, whatever it is, and you will call that as zero error. See how there are two kinds of errors. I'll try to write it on the upper hand side of the screen. Yeah. See here on the upper hand side of the screen, I'm trying to tell you that there is some concept called as zero error. What is zero error? That whenever there is nothing that you're holding in your vernier calipers, but still some reading is being given. How? Just have a look. This is your vernier calipers. You don't have anything over here. Still what is happening is there are two cases possible. Either your zero of the vernier scale, right? Zero of the vernier scale will lie behind the zero of the main scale. This is main scale and this is vernier scale, right? This is called as, this is called as negative zero error. Negative zero error. If the zero of the vernier scale is lying ahead of the zero of the vernier scale is lying ahead of the zero of the main scale, then it is called as positive zero error. Right? I'll try to be more precise. Yeah. Please note it down with you, right? If the zero of the vernier scale is lying ahead of the main, that zero of the main scale, then it's called the positive error, else it's called the negative error if it's on the other side, right? When does this happen? If there is nothing, if there is nothing that you have kept between the jaws and still you are being shown some reading, right? So that will be called as zero error, correct? So zero error will also be some divisions, right? Some divisions ahead or some divisions behind. So such kind of error is calculated by whatever is the divisions, right? Whatever is the division difference that is coming into the least count, right? So this will give you a zero error reading, right? That zero error reading, so the corrected reading, I'm writing on the bottom, have a look here, corrected reading will be equal to always whatever total reading that you have got, right? Total reading minus zero error, minus zero error. So what is the difference whenever you have a positive zero error? Suppose the positive zero error is 0.01. Okay? So you will write total reading. How much does the total reading come? 2.5 minus 0.01. Correct? Whatever will be your answer, right? Or let's say zero point 0.1. Let us keep it more precise. So I'll have two kinds of errors. I'll write it even clearly, right? So you have, suppose the positive zero error. If you have positive zero error, I will call it as ZE is equal to plus zero point 0.1. If it's a negative zero error, I will call it as minus zero point 0.1. Suppose, I'm just taking an example. Suppose you get the answer as zero point 0.1 as the value of positive zero error, then you will write it with plus sign. If you get the answer, if you get the negative error, right, this one, right, then you will write it with minus sign, correct? After you do this, you have to substitute that in this formula. See, you have to substitute this in this formula. See, if it's a positive zero error, what will happen? You will write here minus and then whatever value of positive zero, that is plus zero point 0.1. I've written 0.01. I'll just erase it, right? So you will have either the answer will be corrected reading is equal to total reading. How much is total reading? 2.5 minus of, either it will be a positive zero error, right? Or it will be 2.5 minus of a negative zero error, whatever it is, right? This is your value of corrected reading or correct measurement. Am I clear, class? Am I clear to everyone? This is what I wanted to convey. That I'll revise, right, quickly. So in the question you were given that least count of the instrument is equal to 0.1 mm, right? Apart from this, you are being told that uh, you are given what is what is MSD, right? What is the main scale division that is coming? What is the vernier scale division that is coming? The reading is given, right? How will you get the reading? You will get the reading MSD. First of all, MSD is that division of the main scale with which zero of the vernier scale is coinciding. Have a look here. Zero of the vernier scale is coinciding with one division, with some division of the main scale, and in our case that is second. So therefore we wrote MSD is equal to 2. Then VSD, we wrote VSD is given as that division of the vernier scale with which any division of the main scale coincides. So here we saw that it was the fifth division of the vernier scale which was exactly coinciding with some division of the main scale. That is irrelevant which division, because we are focused on VSD, right? So we'll write VSD is 5. Then we wrote that there is something called as MSR and BSR. MSR is whatever main scale value we got, that is 2, into what is the least measurement that the main scale can make. So least measurement that the main scale can make is equal to in our case 1 mm, right? So we'll multiply that MSD into 1 mm. After which we wrote VSR is equal to VSD into least count of the apparatus, right? So we got VSD as 5. Least count for the apparatus was given in the question as 0.1, right? So we multiplied these values by their respective 1 mm or 0.1 mm. We got the values of MSR and VSR, after which we wrote that total reading is nothing but MSR plus VSR. We added them, we got the answer as 2.5 mm. This would have been the answer if there was no zero error. Then we introduced what is zero error. Zero error is nothing but when there is nothing between the jaws, but still you get some difference between the zero of the main scale, zero of the vernier scale. Because the ideal condition should be both should be coinciding. Zero of the main scale should coincide with the zero of the vernier scale in ideal condition. That is no zero error. But if they don't coincide, then we say that if the vernier 0 is lying behind, then it is a negative 0 error. If it is lying ahead, then it is a positive 0 error. Correct? Then we told that we write 0 error in terms of plus or minus sign, right? Depending upon how many divisions are lacking. Like let's say 2 divisions. So you'll have 2 into zero point 0.1, right? That will give you 0.2. If here there are 3 divisions, so it can be zero point 0.3, right? And then you will write that 0 error with its sign. It will be either positive or negative, whatever the case might be, right? Accordingly, you will substitute that value in the final answer. What is the final answer? It is always given as corrected reading is equal to total reading minus 0 error, right? 0 error you will write with sign. You can today evening when we'll be doing the practice, I'll give you some questions on this aspect. I think that will help you out a lot whenever it comes to solving such questions. Correct? So these are the majority kind of or variety of questions that we have covered in today's class, right? Yesterday we covered the concept of screw gauge, the formula for screw gauge. Today we saw the working of vernier calipers, right? We saw how dimensions work, right? There is just one small topic called as significant figures, right? So I'll be sending you all, there are some rules of significant figures which you should remember before solving any problems, right? So I'll be sending you those rules, right, along with the assignment. So and the dimensions, right? I told you about the dimensions which you have to learn, 5 dimensions a day, and I'll be sending you the rules of significant figures. So you have to remember those rules to solve the significant related questions. So and along with the assignment, right? So I'll be sending you all this. Let us meet today evening between 7 to 8, where we'll have the further discussion. If you have any queries with regards to any of the questions or concepts which we have discussed today in the class, please feel free to forward them to me today in the class, right? During the class, you can ask those sessions, those queries. Yesterday, we had a very interesting session, right? So let us meet today evening once again at 7 o'clock, right? In the evening, and we'll discuss the assignment which I'll be sending you now. So with this, we are finishing the first chapter, that is measurements. Tomorrow, with the new class, we are going to start off with kinematics, right? And we'll also see some basics of differentiation, integration, and the formulas, right? And in case some any other mathematical tool is required, we'll also do a quick revision of the same, and we'll see past year questions. Today, I'll be sending you some more past year questions in the assignment. Try doing it, right? They will be from past year NEET and IEEE and JEE main questions. Try doing them. Ask the doubts in the class today evening, right? Thank you, everyone. Thanks a lot. And with this, let us complete with the session. And I'm so grateful that you all waited so patiently, right? With this, for me, for all of you, right? For everybody in the class, for a little more than the time that we had initially decided. So thank you everyone for being so attentive participants and listening to all the questions, interacting whenever you had any queries. Thank you so much. Any queries, please forward them to me in the evening class from 7 to 8. It is compulsory for everybody to come, as I had told yesterday, that unless you come and practice, ask your doubts. You won't get that concept clearly. You might be fooled into believing that maybe I know it, maybe I don't know, let's let it be. But that is actually causing you to slip out on that concept. Please don't do that. If you have worked hard so much until now, continue it and keep going. Also, as I told you, have the habit of solving at least one paper every day. I had given that tutorial in the beginning of the session. If you have any queries with regards to Zoom technical issues or giving the papers, just let me know on WhatsApp. We can have a discussion on the same, right? Thank you, everyone. Thank you so much. Any queries, we are meeting today and discussing your assignments and your queries 7 to 8. Thank you. Thank you all. Thanks a lot. All the best and keep going. And please make sure you solve at least one entire paper every day. At least for physics, you do it. About your other subjects, it is at your discretion. For physics, please make one paper every day, even if you're unprepared, and revisit the topics for the revision, right? At your own, right? And you can ask any queries in the respective classes we are conducting, right? Also, after 18th, you all can stay connected with me and keep asking your queries. No worries. I'm always there. All right, class. Thank you. Let us meet today in the evening. Thank you, everyone. Thank you so much.